it all started for me with this quest to figure out how flying saucers operate. That led me to this guy, Jeremy Reese, with his YouTube channel, Alien Scientist. I was dealing with similar stuff to what you were doing in the beginning with gravity capacitors and ion lifters and such. And in my first video with him, I was very excited about it. I did a video with Jeremy Reese, live YouTube, and I was reading all the comments. And some guy commented, "Why don't you check out this Alzofon experiment?" And I'd never heard of it before. And I showed it to Jeremy, and he never heard of it before. And he is supposed to be the matter expert, subject matter expert for YouTube at the time, and he never heard of it. So that struck me as strange. And then I looked into it a little bit more. What they were saying essentially comes down to is that DNP is anti-gravity. When you nuclear orient the subatomic particle spins, matter becomes weightless.
Okay.
And that struck me as logical. It kind of makes sense. And the more I looked into it, I found that it seemed like there was a cover-up of this technology or talking about it in this manner. You could barely find any reference to Alzofon online, even though that he has published, his son at least, has published several books on the subject matter, and they are, they weren't doing very well on Amazon. Very few people have heard of it. So I started getting interested in it, trying to figure out what it was that I would need. And in the course of that, I met up with this kid, Jeremiah Pop, who came down, and we built our first rig for testing this this effect. But essentially, what you need is a laminar or homogeneous magnetic field and a pulsing RF source.
Well, so
microwaves.
You actually have David Alzofon's book with you today, and you have some of the others too. Do you want to hold those up? Or?
So the way the Alzofons came up with this theory is Frederic Alzofon was a physicist, theoretical physicist. He learned under some of the top disciples of Albert Einstein about general and special relativity, so he understood it pretty well.
Yeah.
And he was also a physicist in Cal Berkeley, and one afternoon they were driving, I think on the I-5, somewhere here in California, and they had a close encounter with a flying saucer. It flew right over their car. So the family just, okay, they're real. Okay, there's something here. There's something that science doesn't understand. Then the son, David, walked into a bookstore and found this book, Ufology, by James McCampbell. And on page 108,
you might want to hold that up so that we get it.
107, 108, it talks about this encounter that happened with an AWACS plane, basically an airplane that has detection equipment for RF, and it can interact with RF stuff. It can jam different pieces of equipment. It's one of the mainstays of the U.S. Air Force. You see them sometimes. They have this weird round pancake kind of thing on top. So this was an early version of it. It happened over the Gulf of Mexico. And what they discovered was there was a very strong microwave pulse coming off of the craft. At around 3 gigahertz, it was pulsing at 600 times per second, 200, I think 4 millisecond pulses or something like that. It was very specific information. The case was supposed to be part of the government's UFO investigation, Project Blue Book, but it was removed on national security grounds.
Oh. Okay.
Now, it's kind of understandable because this is one of the only cases that has empirical evidence as to what is causing these craft to fly.
Yeah.
Now, when Frederic Alzofon got hold of this book and read those few pages, he immediately thought that this has to be connected to some unique state of matter that he's heard of before, but he couldn't quite name it. He went to a library, a technical library, and he was searching through the books over there, and this book, not this exact copy of it, but this book, by C.D. Jeffries, Dynamic Nuclear Orientation, fell off the shelf in front of him and onto the floor.
Okay, so fortuitous at the least.
I don't know if it was fortuitous or this was, there was a poltergeist in the building, or somebody from Interstellar was going through the wormhole and pushing it off the shelf, but it fell off the shelf in front of him and onto the floor. And this book is literally it's the holy text on dynamic nuclear orientation from the time. And Actually, we spoke to somebody at lunch today. There's really not much else that's better than it, and it was published in 1963. So it just comes to show how important this is. And what they did with that was they went and ran an experiment in 1995, and this was after many attempts to raise funding. They were never able to raise funding for it because it went against the mainstream science direction. So they're never able to really raise money for it, but what they were able to do is borrow, quote unquote, equipment from the University of Seattle, and they used it in the basement of the University of Seattle, and they were able to do this experiment where they lost 80% of the weight of a 1 gram sample within 1 second of running a DNO experiment, or dynamic nuclear polarization as they call it over here. So what happened after that was a clash of egos. Everyone was very excited, but also everyone wanted a larger chunk of the pie, and apparently there was IP involved from the nuts and bolts IP, and nothing ended up coming of it. The lab at University of Seattle needed their equipment back, and the experiment was not replicated by Alzofon again. They did try again in another lab with a lot less success. That was with George Hathaway. That attempt did not involve some of the original participants in the 1995 experiment, who actually where they actually achieved the 80% weight loss.
So you have a copy of what Alzofon wrote as well. This all is kind of the backstory of what led to this.
Oh, so actually David Alzofon came down to the lab and got a picture of him, and he actually commemorated the story of what happened with this book.
Well, yeah, and that's an important
point.
Right? Yeah, so you have worked with David. David is, again, Frederic Alzofon's son. Frederic is the one who came up with this model. David has kind of tried to keep that legacy alive, right? And I mean, I've talked to David myself several times. He has been a part of your life for the last several years now, and he's been very supportive too.
Yeah, he's been very supportive. I must say he's not really a nuclear physicist at all. He's more, his main interest is playing guitar and music, teaching music and all that. But he did write the story of what happened, and he has 2 books, Anti-Gravity with Present Technology, and he also has the top 10 UFO questions, riddles, that he published and are available on Amazon today. And he wrote in here, actually he came down to visit the lab in September 20th of 2023. Says to Mark Sokol, this is the book that launched 1,000 ships. At least we hope so. In 1976, after sending my dad Ufology by James McCampbell, which is this book, which contained the 1957 U.S. Air Force sighting report on the date of the microwave output of a UFO encountered over the Gulf of Mexico. A light went on in Fred's head, and Fred went over to the technological library to look up something on a state of matter. He was randomly scanning the shelves when this book literally jumped out and fell onto the floor. He picked it up, and lo and behold, it held the key to everything. Drink deeply of the wisdom contained herein, and let us conquer the stars with gratitude, David Alzofon.
Well, there you go. And so that I mean, in a roundabout's way. And so it hasn't been a direct path here, and it's probably not worth going into all the twists and turns, but you have built and tested, I mean, an ungodly number of different reactionless drive ideas, but this is the one that you've stayed with, right? This has been your baby in a sense.
Yeah, because I see a future with it, and I think with the other reactionless drive ideas, like propellantless propulsion with inertial propulsion devices.
Yeah, you've done inertial, you've done superconductors. I've seen you do experiments with those. You've done a number of variants on B-field Brown, played with ion wind.
The thing with all of those is they have very weak forces for the amount, and there's theoretical limits to what can be achieved. With dynamic nuclear orientation, the theoretical limits are 100%. It's achievable. Actually, we've been to presentations where they're talking numbers in the 90s that they've achieved, and they're proving that they've achieved. The only thing that they're not doing is they're not measuring the weight. And when I'm talking to people here at the conference, one of the main things they ask me is, how in the world do you measure the weight of a sample that is undergoing DNP, or dynamic nuclear polarization? It's not a trivial task, because in order to achieve these states, you need to have extremely high control over the environment. You need to have very homogeneous fields. You need to have the microwaves interacting with the matter in exactly the right orientation. It can't be this way, it got to be that way. It has to be orthogonal to the standing magnetic field. So, and then in order to know that you have it, you have to have some NMR probe that's going in there, and you're looking at the signal to noise ratio of your NMR to know that you're actually achieving the dynamic nuclear polarization. There's a lot of things going on, and they're also trying to add in cryogenics, or cooling down the sample to ungodly low temperatures near 0 Kelvin for some of the stronger effects. So getting a weight measurement is prohibitively difficult, especially you consider condensation. Just the air hitting that area would give you ice crystals, and suddenly your sample weighs a ton more, because now you're weighing all the water too.
Well, and again, just for the audience, I mean, you have built an incredible lab, and you have a growing collection of equipment, and you're building more and obtaining more. A lot of that is very high quality scientific equipment that you've managed to find. A lot of that stuff is when a lab goes out of business, they change ownership or whatever, right? It ends up in these surplus places. You've been able to find a lot of that.
The surplus places are otherwise known as eBay. That's where it mostly is. But we've been very fortunate to be able to find lots of this equipment. We actually put together our own replication of the Alzofon experiment, and we're here at the ENC Conference 2024 to show everyone what it is we're working on. And we have a graph of a weight change over time as the magnetic field changes, and we've overlaid actually a couple separate runs, and they're nearly identical, as you can see over here. This is weight change over time as the magnetic field is swept. The sample is hanging from a string. The scales on top of a Faraday cage to keep the microwaves from interfering, and we are seeing some signal there. Now, this is not 80%. This is actually not even 1%. This is 0.75% roughly weight change from top to bottom. But what's interesting about it is it's happening right at the Larmor frequency precession, right where EPR is expected to happen. That's where the biggest curve there takes place. So there is some interaction. We've shown this to many folks over here. We've got a lot of interest. One thing we have not heard is that somebody else has tried this. Nobody here has ever made the claim or have ever heard of somebody trying to weigh a sample as it's undergoing DNP. The primary use of DNP over here at the ENC conference is to increase the NMR signal to noise ratio. And in doing so, you're able to take biologicals or non-biologicals in vivo, various different types of materials, and you're able to actually learn what they are. And if you go to a lot of the presentations here today, or the past few days, you'll find the minutia and detail that you can get to of learning what a specific molecule is made of. You can figure out where one atom attaches to the other one in this complex molecule or polychain. And some of these things have implications for genetics, for genetic outcomes, and for mostly for biological and biomedical businesses. They're very prominent in this field. That's where most of the money is coming from, is from biomedical and cancer research. There's also a lot of
you talked about drug discovery, and
drugs,
identification, and
drugs, and certification that the sample, this batch of aspirin that Pfizer made, for instance, is pure enough. I don't even know if Pfizer makes aspirin, but Bayer does. But they need some way of certifying that, hey, this is at least 97% pure, and so on. So, and NMR is really the only tool to do it. But sometimes NMR is just not sensitive enough. DNP increases the sensitivity of NMR
Well,
and
and
that's all
again,
they're using it for.
again, what interests me about this, and I've said this several times, is from what I've seen, this is primarily used for metrology, which is incredibly valuable, very valid, very important, but it is also very passive, right? You're trying to determine what a sample is composed of. What makes you really unique is you were like the first person who's looking at this saying, okay, we want to actively change a material, right? So
I'm not only saying that we want to actively change, I'm saying that the people here who are running DNP experiments are actively changing it. They just are not measuring it. And I believe, if this effect is real as described, turning the effect around, instead of having it inside of a magnet, you could have the magnet inside of it and the sample on the outside being the hull of the craft. And DNP, as we understand it, is contagious. It affects matter around it. So if you're surrounded by dynamically polarized matter, everything that would be inside the craft would also be affected by it. So if it becomes weightless, the entire craft would become weightless. And the implications for that is space travel, interstellar travel, mining the asteroid belt, moon, Mars, habitation. The implications are profound.
Yeah. Well, and again, this goes back to the original idea of UAP and the 5 observables, right, that Elizondo has talked about and others. And, the incredible acceleration, the hairpin turns at high speed, the apparent transmedium travel. These are things that would tear apart a traditional airframe. They would liquefy a traditional pilot. And so there has to be something different in terms of the physics that they're doing. And that's something that many, many PhD physicists have outlined when describing UAP, right? That they've said, look, they're using some kind of physics that we're just not familiar with.
Right.
So
kind of coming here and we're saying, actually, we're very familiar with the physics. We just haven't recognized the effect.
Yeah.
Which is astounding, which kind of screams cover up, because, how could you have a technology that's been understood for 70 years? It's been discovered in the 50s or the late 40s, right after radar was discovered. How could you have a technology that's that old that they haven't looked at the weight of matter? And it's a very simple test to run.
So we've got your books, Ufology, Dynamic Nuclear Orientation,
and this is
Alzofon this is around 1981 something, right?
Right. Actually, that's the newest of the 3.
Oh, okay.
Ufology by James McCabe is an older book, and C.D. Jeffries even older. I don't know if you noticed, but these books are falling apart, and the reason for that is there hasn't been any reprints of them. There has been an attempt at reprinting the C.D. Jeffries book, but what they're actually reprinting is pictures of the book.
Okay.
Michael Perrone actually got a copy of that. It is illegible. So if you actually want to read this book, get yourself a hard copy, the yellow cover.
So what are your thoughts with the UAP thing? So the Office of the Director of National Intelligence has stated unequivocally that UAP or UFOs are real and they pose a risk to flight safety. So that's kind of an inspiration to you. But what are your thoughts on the narrative, right? Which parallels what you've been investigating in a way.
Yeah, it doesn't really change my opinion much. I came to the realization that UFOs were extraterrestrial in origin, at least some of them are. And what the government is saying today in 2024 or 2023 doesn't really change that very much. You could look back to the book The Day After Roswell by Philip J. Corso. He was the second in command at the Pentagon, and he wrote a memoir, basically a tell-all, saying, yes, I've played with UFO parts for 30 odd years and dissected these things and hand them out to companies like Bell Labs and that went on to develop amazing things with fiber optics. So I didn't need any more information than that to know that there was a cover-up. Also, people need to realize that the level of secrecy surrounding atomic research is higher than the government, than most government officials or elected government officials have access to. So the president wouldn't have access to
nuclear secrets.
Well, that's an important point. Yeah, and that's something that I've read is so if I understand correctly, the Q clearance is a Department of Energy clearance that's nuclear related. That's something that the president doesn't have, and it's mandated by Congress. So if I understand this correctly, the president can't just give himself a Q clearance, whereas with any other clearance, those flow from the authority of the executive branch. He would naturally have those, right? So that's my understanding. I could be mistaken on that.
Yeah, I'm not sure about the Congress part, but it sounds right. Also, there's need to know, and they found ways to compartmentalize this to the nth degree so that they're able to keep it out of the prying eyes of politicians who would be interested in learning and teaching everyone more about it.
So one of the things that excites me about what you're doing, I mean, again, the reason that you're here today, and this is a 5-year journey for you, and it's not over, right? I mean, 5 years from now, maybe we'll be doing another, one of these at the same place, and you'll be showing me the progress that's been made. But what excites me about this is you've got, a couple of different groups. You have scientists like in the SCU who are trying to understand the science, but they're not really doing anything. They're just trying to do analysis. And then you've got the UFO community, which is trying to do a diligent job prying these answers out of the government. If the government has them, the government doesn't seem to want to share. And it seems like there's this stalemate effect for 75 years. You are like this light in the wilderness because you're actually taking action. You're saying, okay, we know enough to start building these things.
Yeah, and that's the kind of attitude you need to have, because you need to believe it's possible. You need to believe that you can do it. And one thing that's also very important, you need to believe that they're not going to come after you.
Yeah.
And the December 16th, 2017 news article by the New York Times where they talked about ATIP, and a subsequent other article from that I saw on Gaia just led me to believe that the men in black are not going to come after you anymore. That there is such a institute. Yes, there was a cover up, but they're not going to cover it up anymore. They're not going to actively promulgate the information. They're not going to cover it up. They're not going to do anything. So they're going to allow it to come out naturally. And that's what I've been seeing happening. In the past few years, the biggest issues have been, problems at our lab, SWR matching and, blowing up our amplifiers, dealing with personality issues. Those have been our main issues to overcome. It hasn't been men in black showing up and trying to steal everything.
Yeah. Well, no, that makes complete sense. I mean, there's so much cultural baggage involved with this, right? And I think that there's just a lot of fear and anxiety, and a lot of that is fear and anxiety about the unknown. And so it's difficult to tell. And then there are stories, and I think some of them may be credible, about things happening in the past, right? People being strong-armed, people being told to be quiet.
Yes. But I have been fortunate enough not to have any of that happen. We have had, to some degree, there's been hacks, Amazon account and whatnot, but nobody has ever come forward and said, stop doing your research.
Yeah.
And that's been the telltale sign. I've researched other researchers that have been strong-armed. They always start off with a warning. We've never received a warning, so we're going to continue forward and keep pushing for the truth and pushing for scientific inquiry into this. And I think we've come to the right place. This is the right place to be for this experiment. This is where we need to be at ENC 2024, and probably need to be here next year as well, to just push forward this narrative that, hey, there's something much more fundamental and much more interesting happening with DNP, other than increasing your signal to noise ratio of NMR. We can actually make spacecraft with this technology.
Yeah.
And people that I've been meeting here have never heard of this before. It's very strange to them, but when they think about it, they're like, why wouldn't that work? Because you're playing with the source of mass.
It's outside of their paradigm. Now, I should ask how
not outside of their paradigm, no. They've never thought of it, but now that they're thinking about it, they realize it could be true.
There you go.
Yeah, and the first thing they ask is, how in the world did you get that measurement? Because they're engineers, and they want to make sure the measurement is correct. They want to make sure that you're doing things correctly. But
Well, and so just, being here for the last few days, I've seen this sharing and growth going on with them as well as with you. And so then the question would be, I know that they're giving you a lot of experimental ideas, right? They're like, you might try changing this, you could get a better measurement if you try that, make sure that you ground this, all these little tidbits. But in terms of your learning takeaways, are you having any paradigm changes from this yet?
Yeah, I mean, they're not really paradigm changes. They're more like, so just to give you one rough example, we found this paper recently about the use of pentacene with a p-terphenyl base mixed together and grown into a crystal. Shine light on it, creates triplet states, which can increase your DNO effect by 250,000 times. I thought I was going to be like the first person to do this, and try it with our DNP experiment. I show up here. There's 5 other teams working on the same thing. There's charts in the poster board. People building the exact same device, one after another. And I'm talking to them, and I found out you don't even need the crystal. All you need is the pentacene.
Okay.
So my entire project was unnecessary. All I needed was that little vial of pentacene, mix it in with some epoxy. So that was a really great, that was a big breakthrough for me, that I actually don't even need all that.
Yeah, it streamlines things. Right?
Yeah, it streamlines things a lot, makes things a lot easier for me, actually.
Yeah. So when you get back now, is it just mostly just streamlining the equipment setup that you have? Are you increasing the size? I think you mentioned that you've blown out amplifiers and stuff as well during testing. So
one thing I really want to do here is to meet the right people, talk to the right people, and get them involved at least on a consultancy basis, so that we don't have we don't blow out our amplifiers in the future. Also, another thing, we were running this experiment at 9.88 gigahertz. That's way up. It's close to 10 gigahertz. The skin depth at those frequencies is extremely shallow. And the microwave penetration of the sample was pretty weak.
Okay.
So the level of DNP that we achieved was probably pretty low. According to some papers that I found from Alverhauser in 1953, the energy could be increased, or the penetration could be increased, if you just lower the frequency, and it's a lot easier to work with. So that's another thing we're trying to accomplish as well, just going down to a lower frequency and seeing what can happen over there. And that would require some radical rethinking of our setup. The space of where the sample can be held is only this large, roughly 2 inches by 2 inches round, so which is fairly large.
Yeah.
But we still need to make sure that all of our RF equipment is going to fit in that space, and it's going to take some radical redesign in order to make sure that happens. So that's why we're here, trying to make sure that our new experimental setup is going to work properly at the frequencies that we want it to. And if we're getting the results we want, we're going to try to start flipping the experiment backwards, have the magnet on the inside, have the hull on the outside, or the sample on the outside, and then the sample essentially becomes a spacecraft.
Okay.
And something else that I discovered over here is this wonderful company out of Switzerland that used their magical Swiss engineering to create one of the smallest three-way or a 3-axis magnetic probes I've ever seen, and it comes together with software that gives you a vector and a maximum amplitude of the magnetic field. This is something we've been dreaming of building, and here it is, a product that is, after 25 years of development, in its 3rd iteration, beautiful, exactly as we needed it. And this is something I've been doing research trying to find these kind of things before. I never found it.
Yeah, well,
and here it is, was sitting on the table. I could play with it.
No, it's a giant benefit, because then you're able to build off of right? Like I think you'd said it earlier, standing on the shoulders of giants.
Yeah,
so.
yeah. I mean, they're going to charge me for it, but yeah, so we'll be able to stand
renting the shoulders of giants.
renting the shoulders of giants,
yeah,
more or
there
less.
we go.
Yes. And then we'll be able to map out our magnetic field and build the hull around the mapped magnetic field, and then we'll have our first true, sized out prototype. That would be really exciting. But we do have to go.
Okay. Well, thank you again, sir.
That was
great.
great.
Thank you again.